Okay, it's Mr. Meanaba with you right now. Sorry I couldn't be in class today, but I'm currently in Vancouver, or perhaps on my way traveling back. Um, Today we're going to talk about some new material that is very similar to what you've already done in class. We're going to be on page 169, if you could just turn your notes to that page. And first of all, I'm just going to start with a little bit of review here. If you see at the top of the page, I'm just reviewing the mole method. And the mole method, I tried to get you to memorize a pattern. And the pattern is grams to moles, moles to moles, moles to grams. Hopefully you remember that. Grams to moles, that we know how to do. Moles to moles, that's where you use your balanced equation to convert from one to another. And then moles to grams. Well, we're going to take this and just change it slightly. We're going to change steps either 1 or 3. And here we're going to either come up with a concentration, or we're going to come up with a volume, or something of that nature. Okay, just a review of concentration. Concentration is usually in what we're going to deal with, moles per unit volume. However, it could be some other units, but for now we're going to use moles per unit volume, and therefore moles would be just concentration times volume. Okay, so let's look at our first problem. Here it is. Calculate the volume of a 2 mole per liter silver nitrate solution that's needed for 12 grams of copper to react according to the following equation. Copper plus silver nitrate goes to copper 2 nitrate plus silver. Well, what's the first thing you notice? If you were thinking that that equation is not balanced, you would be correct. So if you could just spend a few seconds balancing that equation, and let's see if you come up with the same thing I do. Okay, well, hopefully you noticed that the copper 2 nitrate has 2 nitrates. So we're going to need 2 nitrates here. So I'm going to put a 2 in front of the silver nitrate. That gives me 2 silvers. I now need 2 silvers over here. And I think we're now balanced. The coefficients would be 1, 2, 1, 2. Okay, well, let's now see if we can solve the problem. First step, as you might expect, we have to find the number of moles. Now let's just go back to the question itself and see what we have to pull out of it. Calculate the volume of 2 mole per liter solution. Now this, you never start with. That is your conversion factor, okay? And that you're probably aware of already. Anyway, let's keep going. Silver nitrate solution that's needed for 12 grams of copper to react. So that's what we're going to start with. So 12.0 grams of copper. And once again, I'm going to recommend that you put in, while you're solving your problems, what it is that you're actually using. And that'll help keep things straight in your mind. Now we're going to multiply by a conversion factor, and hopefully we'll come out with moles of copper. What's your conversion factor? We should be well practiced at this by now. You should be saying 1 mole of copper, and then finding the molar mass of copper. And the molar mass of copper is 63.5 grams if we look on the periodic table. Now, without using a calculator, 12 over 63, roughly what's that? Now, perhaps some of you noticed that 12 over 60 would be the same as 1/5, and it should be roughly 0.2. If we do the calculation, I think you should come out with about 0.189 moles of copper. Okay, so far nothing different. Let's go to step 2. Using the balanced equation, we go moles to moles. So we say 0.189 moles of copper. Whoops, I'm sorry, I'm off the page here. 0.189 moles of copper, and we're going to multiply by our equation factor to get moles of what it is that we're looking for. And it said calculate the volume of 2 mole per liter silver nitrate, so it's obviously going to be silver nitrate. Okay, so I want moles of silver nitrate on top and moles of copper on the bottom. If I look at my equation, I've got 2 moles of silver nitrate for every 1 mole of copper, And if I do that calculation, I'm going to get twice 0.189, which is 0.378 moles of silver nitrate. Things couldn't be simpler. Final step, find the required quantity, and in this case it's volume. So calculate the volume. This is where we're going to use our concentration. So 0.378 moles of silver nitrate. Again, I'm going to multiply by a factor that's going to give me liters of silver nitrate. And I want to get rid of moles of silver nitrate. Well, in 1 liter, there's 2 moles of silver nitrate. And if you notice that this 2 is just going to cancel with the one before it, so I don't even have to go to the calculator. It's going to be 0.189 liters. And leave it in liters unless I ask for it in milliliters. Okay? So, we went grams to moles, moles to moles, moles to volume. Very similar to what we were doing up above. Okay, let's turn over to page 170 now and take a look at the problem there. Okay. Alright, here we are. When a solution of silver nitrate, there it is again, is added to a solution of calcium chloride, the following reaction takes place. Silver nitrate plus calcium chloride reacts to form silver chloride plus calcium nitrate. Okay, hopefully you've noticed that equation is not balanced. So let's balance it. I've got 2 chlorides here, I want 2 there, so I'm going to put a 2 in here. That gives me 2 silver, that gives me now 2 nitrates. I've got 2 nitrates. Everything's great. Now notice that I put in the state symbols, and it says that silver chloride is a solid formed in a chemical reaction from 2 aqueous solution. What's that called? Hopefully you came up with the term precipitate. Okay, now in this problem I'm just going to do it all in one step, and that's the way I'm sure most of you would prefer. The question asks what mass of silver chloride will be formed when 250 mils of 0.155 mole calcium chloride is combined with an excess of silver nitrate. So now we're looking for a mass, but we're given a volume. Okay, so here we're going to go volume to moles, moles to moles, moles to a mass. And I'm going to point out one more thing. I've said 250 mils here. I'm going to count that as 3 significant figures just to keep everything pretty handy. Okay, so we're going to start with our 250 mils. Now, it's up to you what you want to do. If you want to convert that right away to liters, I think most of you are probably okay with calling that 0.250 liters, or we could put the milliliters into our conversion factor. Let's convert it right away to liters. So I'm going to say 0.250 liters. I want a conversion factor that's going to turn that into moles for me. Well, there's my conversion factor right there, 0.155 moles of calcium chloride. Oops, I forgot to put in my my identifier there. That's in 1 liter of calcium chloride. Now my conversion factor, so I want to get, if I go back here, how much silver chloride will be formed. So I want moles of silver chloride on top and moles of calcium chloride on the bottom. I go back to my my balanced equation, and I see that that's a 2-to-1 relationship. And now I want to convert to grams of silver chloride and 1 mole of silver chloride, and that would be 107.8 plus 35.45. I think that would be 143.25 grams, or let's call it 0.2 grams of silver chloride. 4 sig figs should be enough. So we're going to take 0.25, multiply it by 0.155, multiply it by 2, multiply it by 143.2, and we should be hunky-dory. Let's just estimate. This is a quarter. A quarter times 2 would be a half. A half of 143 is going to be roughly 70. 70 times 0.15, 15% of 70, it's going to be around 10. And if I do my calculation, well, here I'll let you do it quickly, faster, get those fingers flying. I don't know, I got 11.1 grams of silver chloride. So there you have it. Okay, we either go grams to moles, moles to moles, moles to some volume, or we're going to go from a volume to moles, moles to moles, and moles to grams. Or we could go volume to moles, moles to moles, moles to a volume. There's all kinds of different things. We're starting to broaden the number of things that we can do. Okay, at the bottom of page 170, you can see there's some questions for you to work on during class. I'd like you to work on those. And if you've completed those, remember we have a test on Friday, and on that test we'll go over some of the moles, and so you can go over some of the problems that are immediately before this section on the review of moles, and you can spend the rest of the time of class on that, and I'll see you when I get back.